Good morning. I am Bill Aley with Taylor Engineering, and I'll be speaking to you today about a potential meteorite impact in coastal waters off of Miami Beach, Florida. This potential impact structure was observed during a sand source investigation in Miami-Dade County, which was completed as part of the SAD Sand project, which you've just heard a couple of other talks about. This morning, I'll speak briefly about the background of the sand search project, specifically the Miami-Dade County portion, and then I'll introduce you to this unique geomorphological feature observed during this study. I'll focus a bit on the geophysical surveys and the sediment samples that were conducted in the vicinity of the feature. We will discuss some of the current theories on potential origins of the structure, and I'll leave the audience with a couple of remaining thoughts and questions. During the planning phase for the geophysical and geotechnical investigations in support of Part 2 of the U.S. Army Corps of Engineers Sand Assessments and Needs Determination, or SAND study, Taylor Engineering geologists identified a unique relict sedimentary structure in shallow waters near Miami Beach, just south of the government cut channel. I know that a few other coastal geologists from Florida have noticed and questioned this feature in the past, maybe even a couple of the ones watching today. Through this study, we were lucky enough to generate novel data, including sub-bottom seismic profiles and vibrocore sediment samples from several areas associated with the unique structure you will see. A little bit about the background on the bigger picture scope of the sand source investigation. Our scope of work tasked Taylor Engineering to identify and explore all possible remaining beach quality sand sources in Miami-Dade County. Once potential explorations areas were identified and approved by the Army Corps of Engineers, our task was to complete a number of exploratory vibrocore borings, analyze that data, and determine locations and potential quantities of beach-compatible sediments remaining offshore of Miami-Dade County. The first step in our process was to overlay the known coral and hard bottom locations, including a 400-foot buffer, on top of existing bathymetry and other data to determine which areas may be environmentally feasible to extract sediment from. The image on your screen gives you an idea of just how limited these potential explorations are due to the environmental buffers. The figure shown is of the area just around Government Cut, but rest assured that the rest of Miami-Dade County looks very similar to this with respect to amount of spaces where it's feasible to even look for sediment. The hatched areas in the figure are environmentally off limits, and the remaining slivers of ocean floor are the areas that formed our search areas. This slide shows a summary of the results of the sand source investigation for Miami-Dade County. In the end, Taylor Engineering identified 11 viable borrow areas containing an estimated 12 million cubic yards of beach-compatible sediments at the locations depicted in the red boxes on the figure shown. The remainder of this discussion today will focus on the feature circled in red here. By no means was our group the first to identify and question the origins of this feature. We were, however, the first that I know of who happened to collect geophysical and geological samples from the area around the feature, which provided us a unique opportunity to study empirical data related to the curious and widely speculated structure. In fact, the Miami Meteorite crater, as it's affectionately known, has its own Facebook page, and there are a couple of apparently peer-reviewed articles theorizing on various potential origins of the structure. This figure provides a more detailed view of the entirety of the structure in question. The circular portion of the structure on the left side of the screen has a diameter of about 2,000 feet, and the debris or ejecta field splattered off to the right of the circular structure is about 9,000 feet long, and you can see it even splatters across the first reef there. Through this last half of today's talk, we'll talk about details of the data collected and some potential origins of the structure, but I would like to go ahead and address up front two thoughts. which many of you familiar with the area or not, or maybe just excited about the feature, might already be thinking. First, yes, this area is currently marked on navigational charts as a spoil area. It has been marked this way since at least 1970, according to known documents. Second, yes, it's incredibly strange looking for a spoil area, and it does have all the features that are defining of a complex crater structure from a geologic point of view. I'll also point out that the scattered linear structures on the bottom right of this figure are man-made mitigation reef for Miami Harbor, mitigation reef B, and they're not associated with the sedimentary structure. This slide has an excerpt from Miami Harbor dredging plans dated to 1971, which provides coordinates and bounding boxes for two, quote, spoil areas to be avoided. And below there's also a clip from a current navigational chart from the area showing it marked as a spoil area. This is probably more than enough for most anyone to accept this feature as a dredged spoil area, although it's not enough to convince a curious geologist. This slide shows a multi-beam bathymetric image of the Miami Meteorite crater feature alongside of a diagram of typical crater features. Pointed out by the red arrows are what appears to be a central peak and a large ejecta field. Also noticeable are several concentric rings around the central peak, all features, again, definitive of a complex crater. These are structures previously unobserved in the dredged disposal world. So what types of novel data were generated that may give us a deeper insight into the origins of this feature? Overall, in Miami-Dade County, this study collected 52.5 miles of geophysical data and 56 new vibrocore. As depicted on the feature shown, a small amount of the geophysical survey lines were conducted directly over the feature, and 3 individual vibrocore were collected from areas of the feature for verification of sediment types, since the majority of this feature lies within areas that are outside of the environmental buffers previously discussed. Those buffers are shown in white on the figure here. So the red lines and the numbers indicate geophysical survey lines, green dots indicate vibrocore locations, and green triangles indicate magnetometer anomalies. As you can see, the magnetometer was quite active in the area of the feature in question. A couple of seismic images were taken directly across the feature. The top image runs west to east across the middle axis of most of the main feature there, with a red dot appearing above the central peak, which is blown up in the inset. In the end, in my opinion, observations from the seismic imagery are inconclusive, unfortunately. If this was a spoil site, we may have expected to see a pile of sediment sitting on top of a horizontal reflector that would represent the underlying Miami limestone. If this was an impact crater, we would expect to see highly fractured bedrock, and traces of the concentric rings would be evident at considerable depth in the sub-bottom. In reality, the seismic lines ran through this area didn't penetrate more than 5 or 10 feet due to the high frequency setting of the sub-bottom instrument, the presence of high amount of gravel, compacted sediments, and steep bathymetry, which interfered with the return signals. High frequency settings like this are typical for sand studies where we intend to get the highest resolution of the shallow superficial sediments. Unfortunately for crater exploration, high frequency sound waves are quickly attenuated at depth, and they also are quickly scattered by the presence of coarse or highly compacted sediment like we encountered. The seismic results that we see in the end could support either of the two main theories for the origin of the structure. Here are a few more seismic images through the main structure and its rings. At first glance, it appears that we can see it deep into the subsurface. However, upon closer examination, the layers that we appear to be seeing below the subsurface are simply multiples of the surface features. 3 vibrocore were collected from the areas of the feature. As will be expected in the dredge spoils and the meteorite impact theories, sediments collected from each of the 3 core consisted of interbedded sands, gravels, and silty sands. Subsamples of the sediments have been collected and prepared for future microscopic examination, which we'll discuss a little bit more a couple slides from now. As previously mentioned, a few peer-reviewed papers have been published on the structure, and a couple of internet discussions about it can also be found simply by Googling Miami meteorite crater. Prevalent theories on the origins of this structure include those previously discussed, as well as a couple less widely accepted, such as maritime explosion, radial lava flow, and karst solution feature. Maritime explosion is not out of the realm of possibility. However, surely there would be records or recollection of such a thing occurring in our time. Anyone who knows anything about Florida geology can immediately dismiss the radial lava flow theory, although if this image was coming from the moon, it might be a better theory. A peer-reviewed article, again, exists claiming that this is a karst solution feature, also not likely to be accepted by 99% of Florida geologists. In my opinion, still, the 2 most likely scenarios are dredge material spoils and meteorite impact. Let's briefly look a little bit deeper into those 2 scenarios. The dredge spoils hypothesis fits well with the location and the orientation of the feature, relatively matching that of government cut, as you can see in the top right there. The concentric rings in the ejecta field appear to kind of bend with the government cut channel, which is curious. However, to the best of my knowledge, research, and personal interviews in all of the Miami Harbor dredging records that date back to 1905, there are no records indicating that large quantities of dredge spoils have been placed in this area. In fact, the earliest records document using dredge spoils for enlargement of Fisher Island, construction of the port's Dodge Island, and construction of MacArthur Parkway or Causeway, and some of the other local islands that you see in the figure. Dredging projects since at least the mid-1950s have placed dredge material either in offshore dredge material disposal sites, which are 3 to 4 miles offshore, in hundreds of feet of water. Considering that the crater is about 2,000 feet wide and the ejecta field is over 9,000 feet long, it would have taken millions of cubic yards of dredge material to create this feature, and surely there would be a record or a recollection somewhere. As for the meteorite impact hypothesis, we've already looked at the similarity of various structure features to definitive crater features, but let's take a look at a couple of other well-known craters. This is a NASA image of Mare Orientale on the Earth's moon. This is a very old multi-ring complex impact structure that's actually the size of Texas. Here's a little smaller one called the Ricot structure in Mauritania, northwestern Africa. Again, a complex multi-ring crater known to have been created from an extraterrestrial impact. Finally, here's the Silver Pit structure, another complex multi-ring impact structure. This one's buried below the North Sea off of Britain. If this is a meteorite impact crater, how old is it? When was the impact? Meteorite and asteroid impacts have been detected in Florida fossil record from the late Eocene and the early Pleistocene. These correlate with large known impacts at Chesapeake Bay and in Arctic Canada. There are also other known impacts on U.S. soil within recent times, geologically speaking. Based on observations of its erosional status, in my opinion, it's highly probable that the Miami crater could have been formed during the early Pleistocene impact event by fragments of the larger asteroid event at that time. So I've just presented to you a bunch of theories and inconclusive data. What now? First, if anyone finds or has any record of large amounts of dredge material being placed south of government cut, please speak up. Geologically, the next steps to verify the meteorite impact hypothesis are to look for microscopic evidence of an impact within the sand grains themselves. Objects called microtectites or shocked quartz have been found in Florida marine and terrestrial sediments, and these can be correlated with large impact events previously discussed. So, time to get out the microscope. Thank you, everybody, for your time today.